Hi guys, this is Dr. B. This is AP Chemistry topic 5.4, elementary reactions. The objective is to be able to represent an elementary reaction as a rate law using stoichiometry. So the rate law of an elementary reaction, we'll talk about what that is. You can get that by just looking at the stoich. So basically balancing your equation, and from there you'll be able to figure out what is the rate law. And we'll talk about what an elementary reaction is and how you'll want to have those because it'll just make it easier for you to get those questions. But you can only use this technique for elementary reactions. So an elementary reaction is a single step reaction only. So it only takes one step for it to happen, and that's it. So let's look at this reaction. 2NO plus O2 producing 2NO2. It is very unlikely for three particles to collide at the same time in the correct orientation for a reaction to occur. That means it will take place in two steps or elementary reactions. So the likelihood of three particles or more colliding at the same time in the correct way for it to occur, it's not very high. It's not going to happen. So sometimes you end up producing, you have to kind of break up your reaction and you end up producing intermediates. An intermediate is a compound or element, or it's a molecule that is formed in the first elementary reaction and then is used up and is no longer present in the final reaction in the end. That's what is an intermediate. So notice that when you add the two reactions, here and here, the N2O2, that is gone. That intermediate is no longer present. So the sum of the elementary steps is the same as the overall balanced equation. So like I said, an intermediate is neither in the reactant or the product. It's formed and then consumed during the reaction. So because we had two elementary reactions, we can tell if it's just the first elementary reaction that the rate law is rate equals K concentration times the concentration of NO squared. So if that is based on that single reaction, our rate law has to be squared because it's two particles. The rate law for the second step would be rate equals K times the concentration of N2O2 times the concentration of O2, based on that reaction that we saw earlier. Sometimes they'll give us a reaction and they will tell us, oh, it's in multiple steps, but the slowest step is the first one. So why does that matter? The slow step is the rate determining step, meaning that it limits how fast the reaction can go. I'm not going to read that chocolate chop thing because that sounds really good. Like I said, the slowest step determines the rate of the reaction. If the first step is slow, then the overall rate will be based on the stoich for that first one. However, we're going to talk about it later in this unit 5.9. If the second or third elementary reaction is the slow one, that's going to kind of change our process. So let's just focus for now on the first step being the slow one. Given the following elementary steps, what is the overall reaction and what is the rate law for elementary step 1 only? That's assuming that the first step is the rate limiting step. So what is the overall reaction? So we have to look and see if there's any intermediates. There is, H2I2. So that's on both in the product first and then reactant in the second one. Oops. I don't know how that happened. So the overall rate reaction is what's wrong with me today? 2HI gas producing H2 gas plus I2 gas. So then what is the overall rate reaction? Rate equals K HI squared. What's this? So it's a second order reaction. Gaseous cyclobutane C4H8 breaks into two gaseous ethylene C2H4 molecules via a single-step unimolecular reaction. Write the balanced equation for this, and then the rate law. So I have, it only tells us, we'll see, we have C4H8, and it's a gas. It breaks into two ethylenes, and they're gases. If this is a single-step reaction, and it also, you can kind of see it's balanced already. So for this rate law, luckily for us, it is rate equals K C4H8. All right, so if you have any questions, please let me know. Thanks.